Hello, today I want to talk to you guys about the fiber optic safety and some of the tools that you're going to be using. First off, safety. So number one, we want to make sure that we keep all of our food and beverages off the table that we're using to work with fiber. Next, we want to make sure that we use safety glasses. Safety glasses we should use should have side shields on them, so that'll, of course, keep fiber optic shards and other glass particles from getting in your eyes. And speaking of fiber shards, we want to make sure we keep track of the fiber shards. So that leads me to the electrical tape. The electrical tape is going to be used to collect the fiber shards. So I'm going to pull off probably about 8 inches. And I'm going to create a little loop like this. And this loop will be set right up at the top of my workspace so I can place all my fiber scraps on there. When I'm done, I'm going to wrap the fiber scraps up inside of this tape and then throw this tape away in the garbage where nobody hopefully will stick their hand and have any fiber particles stuck in them. Also prevent them from getting caught in your clothes or on the floor and so forth. Next, when we're working with fiber optic cables, we never want to look directly into the ends of the fiber optic cables. So if I'm working with a fiber optic cable like this, I don't want to look into the ends of them. Okay, so the end is where the laser is going to be coming out, and the wavelength that the laser is coming out, you can't see with the naked eye. So even though you don't see a red light, doesn't mean that there's not actual power there that can damage your eyes. A slight glance isn't going to burn your retinas, but overexposure can be bad, especially if we plug this into a 400 time microscope when we're looking at them. So as long as we're talking about microscope, let's talk about that one. So I've included with your kits a microscope. We're going to open these up. This is a 400 time microscope. It is by OWL, the Optical Wavelength Laboratories. And if you look at the end, we can push this button right here and it will light up. You can notice the light just came on inside there. So now when we look through it, we can see when we're looking at a fiber end with the fiber end at the bottom, and then we look at it with the microscope. So I'm going to try to focus this in. So I'll make sure the end is all the way up, and I'm going to turn the part right here, and I'm going to move it right and left until I can get a focus on what I'm looking for. So if I don't move it right and I don't see anything, I'll move it left, and I can see it start to come into focus. So you're not going to be able to see, but that's how you take a look at the end of the fiber. And I'll have some images you can take a look at later on. You might need to make sure that this stays in. So when you push this in here, you might want to kind of put a little pressure on it to make sure it stays in the microscope and doesn't fall out on you like that. Okay, the light should turn off automatically, but if it doesn't, just push this button again and the light will turn off. Alright, so that's the microscope. Next thing I want to talk about is the, if we're going down the list of things that we got in our toolkits, is the swivel eye. A swivel eye is what's used for pulling fiber optic cables. The swivel eye that you received should look like this. And a swivel eye prevents the fiber optic cable, as it's getting pulled through a conduit, from twisting and bundling up in there. So one end of the cable we attach to the fiber, and the other end we attach to the pull rope, and as we're pulling, the fiber is not getting twisted as it's getting pulled through there, which will then break the fibers. Next item is the fiber stripper. So let me get a piece of fiber here to work with. So the fiber stripper is this tool right here. Oops, wrong one. This is the fiber. They both got red handles. So this fiber stripper right here allows me to strip off the plastic coating, which is the color. This is a 900 micron fiber cable. And then it will also let me strip off the tight buffer, which is what is protecting the glass fiber. So if we can see, as soon as we focus, there's two holes here. One hole is larger than the other. Let's see if I can get another focus in here. Okay. And you can see the one closest to me is the smallest hole. Okay, so that's where we're going to be stripping off all the way down to the 125 micron cladding. So when I work with these, I like to hold them like this. So you can see there's the bent part here, and I grab hold of them like this. And I hold them at about a 45-degree angle. Okay, so I'm going to take my fiber, and when I'm working with it, I'm going to first strip off probably no more than about a ½ inch at a time. So what I'm going to do is I'm going to squeeze just enough that I can feel it bite through that blue colored jacket. Okay. And now you can see what's exposed. What you're looking at is the tight buffer. Okay, there is still a coating of plastic on this fiber. So now when I put this back in that first hole and squeeze down on it, I'm going to squeeze down tight all the way, and I'm going to do a refocus here, get a little closer, and you're going to see me strip off the actual tight buffer, and it will come off like a plastic. Oh, let's try this again. Okay, there we go. I'm going to pull the fiber away from the tool. As you can see, that white stuff, that's the plastic stuff getting pulled off. Notice I didn't pull the tool, I just pulled the fiber. So now what I have exposed here is the actual glass cladding. Okay. And here we can see the left on the tool is the tight buffer. That's that plastic coating that protects it. And now that I've stripped off the jacket and the tight buffer, I'm going to strip off just a little bit more, because typically you have to work with just enough fiber. So again, you see how it kind of bent a little bit there. Try to get a new focus here. So now I'm going to strip off again. I'm going to squeeze it tight all the way down and strip off all of that tight buffer. So now I have a decent length of fiber to work with. I'm not going to do anything at this particular moment, but I'm going to show you what we're going to use the next tool that was provided. The next tool was alcohol and lint-free wipes. So the lint-free wipes you got are these little cloth ends, these little cloth, lint-free cloths, and the alcohol. So I provided you with a little alcohol bottle. It makes it easier to dispense it. So I'm going to fill mine up with 91% isopropyl alcohol. And I only need a little bit. Oh, this one has not been opened yet. So we'll pour just a little bit in there. Don't need much. Okay, I have just a tiny bit on the bottom. And what I'm going to do is just squirt a little bit onto the lint-free cloth. and I'm going to place my fiber scrap inside and pull it, and if you can hear, squeaky clean. So it does make an actual squeaky, you're going to pinch tight. So you are going to pinch really tight, pull the fiber, and that will clean the fiber off. We always want to make sure we're working with clean fiber. Okay, so those are some of the tools that we're using there. To continue with some of the safety rules as we're talking and working with fiber, we want to make sure that if those of you who wear contact lenses, make sure that you wash your hands before you do anything with your contact lenses, as well as wash your hands thoroughly before you eat. That can be a problem if you get a piece of fiber that's not stuck in your finger, but possibly stuck on your finger, and it can get off onto your contacts or into food. Also, since we're working with alcohol and other items, sometimes the items we're working with can be flammable. Make sure you're working in a well ventilated area. When you're finished, we're going to clean up everything. So this fiber scrap probably isn't the safest thing to throw into the garbage. So what we're going to do is we're going to put this in our offcut tape. So I'm going to pull my offcut tape onto camera here a little bit, just so we all can see it. So there's my electrical tape. And what I'm going to do is I'm going to use the tip, which will cut the fiber, and I'm going to place this fiber scrap on my offcut tape. So now when I'm done with all of my scraps that I'm going to potentially have, I'm going to take the fiber, which by the way is placed long ways on here, and I'm going to twist, and that will cover up any fiber that I may have. And if you want to, you can kind of grab any of the little pieces like this. You can carefully bend it if you want to bend it, but now you can throw this piece of tape in the garbage, hopefully eliminating anyone from getting injured. All right, other items that came with your kit. Scissors. Scissors are used to cut things like the Teflon strength members. So here I have some strength members, and we use the scissors to cut that because it gets kind of difficult to cut sometimes. Okay, we'll go over that later. Other items that were included is this. This is a loose tube stripper. You can see there's two razors on this one. We have a razor here and a razor here. Okay, one of the razors should be protruding out, and the other razor should be pushed back. So pay attention to that. You might need to adjust the razor. Most of the toolkits that you guys got, most of them, the razor should be adjusted just right in order to cut that loose tube, and we'll demonstrate that in a future lab. Another tool that was sent with you guys is the testers. These are the testers, again from OWL. These are really nice testers. This one on the right-hand side that I'm pointing at, this is the optical power source. So this is going to generate the specific wavelength that we're looking for. So if we're measuring multi-mode fiber, we can set it to a red light, and that's 850 nanometers, 1300 nanometers for green light. If we're testing single mode, we're going to use this port, and we can test it at 1310 or 1550 nanometers. And we're going to be going over how to use these as well. But here are the on buttons for this one, and for this one the on button is over here. This device with just the screen and two buttons is what's used to measure the power, which is dBm, and also measure the loss, dB. You also received in your toolkit various connectors and ends, so let's take a look at some of those. This is an SC to SC coupler. And what it does is it aligns the ferrules so the tips of the fiber line up and match up with each other so fiber can pass through there. So if I were to put an end on, I would have an SC CN like this, and they're keyed, so there's only one slot, and that's where this slot goes through. Slide it in, and it clicks in. So now it's ready to receive on this other end another SC. So I can take this other end and slide it in, and it clicks in. So that's how that adapter works. So I gave you a couple different adapters. We can work through those, take a look at what you got. The other thing that I sent you was the visual fault locator, and this is where it actually injects light. I forgot to mention that this also doubles as not only a meter, but also a visual fault locator. So this port right here is used to actually read the power or the loss. This port on this side is actually used to generate a visible laser light that we can see and test to see if we have light coming out or do a continuity test. So I'm going to demonstrate how to use that real quick. Push and hold the on button. Take a second to boot up. And what we're going to do is we're going to hit this button until we see V, or it looks like a U, but VFL shows up, and now you notice where my finger is, there's a light coming through. So we can now plug in a cable, and it's going to shine a light through that, and if we see the other end, the light is coming out. So now we know that that one has light coming out of there. Pull it out, go back in, and we can see light. So if I were to bend this, bend it too far, you can see the light escaping right through the jacket. So that's the benefit of a visual fault locator, is now we can see that there is a fault right here on this jacket. Right, so do not bend fiber that you intend to use like I just did. But this is a nice little test. You can see the light escaping. And turn it off, just push and hold, and it turns off. So if you received a tester that won't turn on, battery's probably low. So here I'm just going to pull that little rubber cover off of these, and on the back side you can just flip the bottom and put in a 9-volt battery. Put it back in. You don't put the top in first, and then pop the bottom in. All right, let's go over the fiber optic cables that I sent you. So the fiber optic cables that I sent, we'll go over this one first because this is the one that we are playing with. This is called a zip cord. It's a zip cord because it's usually a duplex cable, and I took it apart here just to show you, but it's typically shipped like this. So you can see the 2 fiber optic connectors, the 2 fiber cables, and it's usually taped together in a fashion like this. But I took it apart so we can see the individual little SC connectors. If I grab another zip cord, the reason why they call it a zip cord is because it does come apart like a zipper. Okay? So if we dissect this and take a look at this, I'm going to use a pair of wire cutters and strippers, and I'm going to just cut through the jacket, the yellow jacket, just enough to be able to pull off. And now I can see that you have the Teflon strength members. Yeah, I can cut those. And sometimes these scissors, as they get used over and over again, get kind of dull. And we're left then with the 900 micron buffer that we can then strip off. And that's where we use the fiber strippers. Okay, again, I'm going to hold them where the angle is away. Fingers go over the top of it like this. And I'm going to hold that at about a 45-degree angle to myself. And I'm going to pinch just enough that I can feel it go through the jacket. I'm going to pull the fiber away. I'm pulling the fiber away, not the tool. Okay, so now I can see there's still some of that tight buffer on there. I'm going to stick it back in there, squeeze down all the way this time, and then pull the fiber through, and it will strip off all of that tight buffer. So you can give that a try when it's your turn. Again, this is a zip cord. It's usually comes in shorter lengths, anywhere from 2 feet to 4, 5, 6 feet. There's even zip cord that you can get that's 100 meters. Here's a zip cord that actually has LC ends on them. And again, they come duplex together like this, so you can push down on the end. Notice the ferrule on these is smaller than the ferrule on the SCs. See the difference. The ferrules on this one are a lot smaller than the ferrules on this one. I pulled them apart so you can see that they are just an individual LC end with a tiny little connector, and LC, they're little and they click when they go in and when you plug them into a fiber optic port. So that was the zip cord, typical for just patch cord connections. Another type of fiber optic cable that you received was a distribution cable. The distribution cable looks like this. And if we just look at the jacket here real quick, you can see that actually says 6 fiber riser distribution cable. Okay, OFNR, which means that it is the fiber optic rating is for riser or R, and that means that it needs to be inside of a conduit if it's going to be going through an air handling area. Okay, so this one we can just take a utility knife, and sorry I didn't provide you with a utility knife in your toolkit, but if you can get a little razor utility knife or even a pair of wire strippers, and you can cut just a little section off of the jacket. Okay, do it that way. And usually if we bend it just a little bit, it will come apart, or you can use a razor. Again, careful not to cut yourself. You can just score the jacket just enough that you should be able to pull. Now notice I didn't cut through it all the way, but as I bend it a little bit, the jacket will actually come apart. So pull on it, making sure not to bend the fibers inside. If you remember, it said 6 fiber, so we can see in here, using the TIA EIA color standards, we see, we pull that Teflon strength member away, we have 6 fibers. So blue, orange, green, brown, white, slate. So those are the standard 6 colors in the code. So again, if I want to take a look a little bit deeper, I can take this orange fiber and I can strip that orange jacket off. Again, I'm pulling the fiber away from the tool, and then I can do it one more time, this time squeezing all the way, pulling that tight buffer off. There we go. Okay, and just for safety, I'm going to snip that end off and put it on my offcut tape so nobody gets hurt. Okay. Next type of cable that I sent you was already dissected, but it was this one. And if we take a look at it, it says 4 SMF, so 4 single mode fiber ZWP. I'm not 100% sure what that stands for, but this is armored loose tube cable. So it's armored cable with a loose tube in there. So I'm going to take this apart in pieces so we can see what it looks like. Yours was already taken apart for you. Okay, so I'm going to first cut the black part of the jacket off. I'm going to bend it just a little bit in each spot. Notice how the jacket actually breaks. Okay, and then I'm going to pull. Twisting this a little bit. There it comes. Okay. So you can see here we have a actual armor. This is essentially aluminum protecting the fibers inside. This aluminum is for rodent protection. So if a rodent were to chew through rubber or this plastic, which they like to do, they'll hit this and won't be able to chew any further, hopefully. So now I'm going to take this armor off. So the armor is going to come off using the wire stripper. I'm just going to make a small indentation, and now I'm going to bend it on that particular spot. Back and forth, up and down, left and right, and it should break that foil. So now I should be able to pull that off. So there I pulled the foil off. And you have to be careful working with this. You should be wearing Teflon gloves, but it is just a foil, pretty thick foil wrapped around there. Okay, in here we have water blocking fibers, and so if they get wet, they'll absorb the water. And we also have, if we pull that away, this straw. This straw is the tube that has the fibers inside. So that's why it's called a loose tube. Let's take a look at it. So I'm going to use the loose tube stripper, and I set it down here somewhere. It's behind my lint-free cloths. There it is. So I'm going to use this, put it in the little groove, turn it around once or twice, bend it just slightly on the spot that I cut, and now I see a nice icky mess. That's again, some more water blocking gel, so I need to strip that off. I'm going to get my lint-free cloth, put a little alcohol on there, and I'm going to wipe those fibers clean. Okay, and if we pull them apart, these are a lot smaller. So this is 250 microns. I'll zoom in. Okay, so here we can see the 4 fibers. We have blue, green, brown, and orange. Okay, if I take this orange, pull off to the side just a little bit, I am then going to strip off that type buffer. And there we have the bare fiber. Clean it up. There we go. Nice clean fiber. So this is armored cable for rodent protection. It's got water blocking and strength member fibers inside of the armor. Inside we have a tube. This is a tube with loose fibers. So as you can see here, I can push them in, and I can just manually pull them out. So they're loose inside this tube. And these are 250 microns in thickness compared to this one, which is 900 microns in thickness. So you can see the difference between the two. We're going to be working mostly with the 900 micron thickness fiber cables, but I wanted to give you an example, something to take a look at and experiment with. So again, for safety, I'm going to cut that fiber, put on my off-cut tape, so nobody gets hurt. All right. The last couple things that I sent you are connectors. So let's take a look at them. I'm clean up my workspace here a little bit. So some of the connectors I sent you are these. These are new ones that we're going to be playing with for this class. Zoom out a little bit. This is the clamshell that they typically come in. I'll take that out and take a look at this one as well. Okay. So the difference between these two, they're both SC connectors. So stick and click, and the difference between them you can kind of guess by the color. One of them is green, one of them is blue, but the actual real difference is this one, the green one, is an APC, angled physical contact. So this type of connector, the ferrule, the tip, is angled. We'll look at that in a second. This one is just a standard SCP. Typically blue SCP means that it is a single mode fiber. If you saw a beige color, the beige color, which is this one, is typically multi-mode. So those are the typical colors you'll see. Multi-mode, single mode, and this is typically single mode APC. We don't see multi-mode APC. All right, so let's take a look at the real differences. So I'm going to take these little connectors off to help keep it in, and we're going to take a look at the ferrule for the, let's flip it around this way, for the standard SC. Zoom in a little bit more. Standard SC, you can see the very end is flat. Okay, it's a 90 degrees from here to straight back. So 90 degrees, flat, physical connection. So if I can hold my pointer correctly, that's flat. Okay, now let's take a look at the APC end. The APC, you can see, is angled. So you can see my end, my little pointer, I put it at an angle because that's the angle of the end. Not only is it angled on around the ferrule like this is, it comes to a point, but that point itself is also angled. So we have an angle here for the APC, and we have flush for the standard SC. All right, and we zoom out here. I'll show you one other type of connector that I sent with you guys. Actually, we have two more left. Oh, that's the wrong box. Let's try this box. Aha, here we go. So you should have a connector that looks similar to this. This one is the SCP, I'm sorry, the SC connector, but it is a different type of fast connect. So all of these are pre-polished, meaning they already have a piece of fiber in the tip that's been polished at the factory. But this one goes on a little different. So you want to make sure that before we use this one, that you make sure that this is pushed all the way inside. So I'm squeezing this down, making sure that this is pushed inside of the connector. Okay, the moment I pinch these together, you hear it click, it's going to release the mechanism that holds the fiber in. So the ultimate goal is you're going to slide the fiber in here and then pinch this, and it will trap the fiber inside the connector. So if it is loose, and you did pinch it like this, and it's loose, you're going to want to push it back in all the way till it clicks in nice and solid. Okay? So again, we're going to be sliding the fiber in. Once it's in all the way, I'll demonstrate how that works. We're going to pinch this and pull this off. Okay? But if you've already pulled it off, we want to put it back on. and we want to make sure that we push it all the way inside so it's solid and it opens up that connector on the inside so we can slide the fiber in. The last connector that I gave you guys was an SC. I apologize, it is not sitting there, so I need to grab it. The ST connector that I sent you comes in a box like this. We have a lot of them, and these are how they arrive. Let me zoom out a little bit. Okay, and this ST has no fiber in the end, and we can't see it right now, but if we take a look at the microscope, we can see. So these are called stick and twist, ST. We stick the fiber in the backside with some epoxy and stick it in so the fiber comes all the way out the other end, and then we need to scribe the end off and polish it. I did not send you with tools in order to do that because of the complexity of trying to do it in your own home lab. It's kind of difficult. So, but what I did provide is you should have one of these that you can take a look at. It comes with a boot, and this helps support the fiber as it's coming out the back. So you can take your boot off if you want to. Put it on. And it should have also come with a dust cap. Here's the dust cap. Put that on. So let me zoom in. So how these work is when you put it into the adapter or to the equipment you're using, you stick it in and then you twist it. And what happens is this is on a little spring here, and it twists in and locks into place. So that's the stick and twist, ST, fiber optic end. Well, that concludes all the different types of cables and tools that you got in your kit. If you have any questions, feel free to contact and reach out to me.